Hello everyone, welcome to our learning journey on segment routing basic to advanced. These are some series of the sessions, and today in this session we will be particularly talking about different type of prefix sets and then one analogy as well that in my opinion these operators should keep in mind when they are enabling segment routing. So, with that, let's just get into today's agenda. And I would like to start with that analogy itself. So, segment routing control plane. There are different control plane options that exist in segment routing. If talk about SRMPLS versus SRV6, and then if we include even the SDNPs into it. But for this analogy, what I will be talking about is SR MPLS, and there as well, where we have an IGP, whether it is ISIS or OSPF, does not matter. As we had seen in our previous series of videos, that now it is the IGP which is responsible for distributing the labels. As we are talking about MPLS, the fundamental principle for data plane forwarding in MPLS is you need a label. But basically, what are those prefixes to which you should be assigning a label? I can have n number of IP addresses on a node. Does that mean I need to assign the label to all of that? And basically, this type of queries is what I get. So, to answer this, when we are talking about IGP, don't think that it is a truck which can carry all your garbage where you assign a label to all your IGP destinations. Basically, when you are enabling segment routing in your network, think of IGP as a luggage that you are carrying on a flight. Here, this luggage has a limitation. Normally, it is 15 kgs in most of the flight or 20 kgs. That means you can only take whatever is essential. What does that mean? That means that in our context, when you are planning for segment routing, you should have the labels allocated to the seeds which are absolutely necessary, not all your prefixes. What I mean by this will be more clear in our upcoming slide, so stay tuned. But take this as a design guidance, and I'm pretty sure that this will be clear once we go to the next two slides. So with that, let's just introduce what a prefix SID is. So as I was saying that you have or you can have multiple prefixes allocated on a router. You can have multiple loopbacks, you can have multiple interfaces where the IPs are assigned, and your IGP by default distribute all these prefixes reachability information. But then when you allocate a SID to it, when you allocate some segment identifier, that act as a stepping stone for this SR based solution. And normally what you do is you assign only one prefix SID to a prefix. Let's say if I have a prefix which is 1.1.1.1/32, I will allocate a prefix SID of 1001, just for an example. And then this prefix SID cannot be allocated to any other prefix in the same domain. This has to be unique. And now going back to the previous analogy, SR specification basically allow you to assign prefix SID to any prefix. This is important. As per specification, you can assign a SID to any prefix. But then that's where you need to think, because it is the IGP which is carrying these prefix SIDs for you. There is no LDP now in SR. You need to think of this IGP as a bag that you are carrying in the flight, not that truck which I had shown earlier. That means you should not be allocating the prefix SID to each and every prefix. As a best practice, you can do that just with the loopback prefixes. So in practice, the SIDs are assigned only to the loopback addresses only. And then one another aspect before we leave this slide, as I was saying, that this SID should be unique in the domain. And during interactions, customers do ask that is there a automated framework that exists which can ensure that these prefixes are unique. While there can be a framework, I'm not denying that, but treat this prefix SID like your IP addresses. You need to ensure that there is no IP address conflict in your domain, and you assign the IP addresses only once, and then it just stays forever in the network. The same goes with these prefix SID as well. You need to assign it only once, and then it will stay there for the lifetime of that network. So now you can think whether you need a automated framework, or as it is just a one time activity, automation may not make much of a sense here because it doesn't change like your IP addresses. So with that, let's just move on to our next type of prefix SID, which is a node SID or a node segment. So basically what it is, a node SID is a special type of SID that actually identify a specific node. And how can you identify a node? I can have a loopback interface on this node, which is, let's say, a slash 32 mask, and I can identify this node with this particular IP address. And I can very well have a prefix SID associated with it, as I was saying earlier. Because this is a prefix on this node, but this is a host route, so node SID can be a subtype of a prefix SID. And all that happens in the segment routing is you allocate or you assign a prefix SID to this loopback addresses, which you call as a node SID. And just to reiterate, this SID in MPLS data plane is nothing but just a MPLS label, because that is what MPLS need when it comes to the forwarding on the data plane side. But here it is a node SID, that means slash 32. Earlier case was a prefix SID that can have basically any IP address in your network. So node SID is a subtype of a prefix SID. But is that it? Or there is something more to it? So if I look from the data plane perspective, basically there is no difference at all. Your prefix SID, let's say, can have a label, and your node SID can also have a label. but make sure they are unique, right? That's the first principle. But then from the data plane perspective, they are just the label for me. But what does it mean? When I say there is no difference from the data plane perspective, all you will see is the label in the data plane. But does that mean that there is a difference from the control plane perspective? The answer to that is yes. These node sets during advertisement are advertised with a special flag bit. So your node sets are always advertised with this flag bit set. Why basically we need this flag to be set for the node set? This is something that I will be talking in our future videos, so stay tuned for that. But for now, understand this: if it is a prefix seed, this flag will not be set, but if it is a node seed, this N flag will be set. And I will show you this in our next video when we will be talking about how IGP basically advertise these seeds. So now coming back to our discussion, we have talked about prefix seed, we have talked about node seed. Prefix seed can be any prefix where you allocate a seed value. Node seed specifically has to be a host route. Are there any other type of seeds as well which exist? The answer to that is yes. So let's just see that. The next type of seed that we have is anycast seed. And this type of seed is basically allocated to the anycast prefix address. Anycast address is something where we assign the same IP address, let's say 1.1.1.1, to multiple nodes. And we do this for multiple reasons. It can be for redundancy, it can be a specific region where we want our traffic to pass through. And I will come back to this region thought in few seconds from now. But all in all, you allocate one anycast address to multiple nodes. And now, with the SR context that we are discussing, you allocate a SID to this prefix, which is your anycast prefix. That means 1001, this particular SID represent all these nodes. So an anycast SID is associated basically with the anycast prefix. That means it represents these group of nodes that we have here. So what could be the use case? Why in the first place you will allocate anycast SID, right? Before I come to that, let's just see what nodes we have on the slide. So let me clear this ink and come back here. So from the definition perspective, anycast prefix with associated prefix SID identify a group of nodes. And as these are group of nodes, not a specific node, that means anycast SID is not a node SID. What does that mean? From the control plane perspective, N flag will not be set. And I'm talking about this N flag. I will talk about this control plane difference in some of the upcoming video for sure, so stay tuned for that. And now coming back to our anycast SID, as anycast prefix is assigned to multiple nodes, that means this anycast SID does not indicate any specific node, but it represents a group of nodes. But you may be thinking, why in the SR we are talking about Anycast segment? To give you an example, I was talking to a customer which has its presence in APAC as well as in the EMEA region, and they had certain compliance requirement which says that any traffic which goes out of EMEA heading towards APAC region should pass through data centers in Netherlands. So these data centers which were there in Netherlands, there are multiple such nodes. So what we did for this customer is we assigned a anycast seed which was same to all these nodes, and when the traffic was going from EMEA to APAC, this anycast seed, which is let's say 1001, was put in the label stack. So when the packet was getting forwarded, this label was allocated to these group of nodes, these group of transit nodes, and it has to pass through any of these nodes in this data center to meet that compliance requirement. To put it in a more simple way, let's say if I have a network like this where I want traffic from R1 to this node, let's say R6, I want that to pass through via this region where I have group of nodes. So what I will do, I will allocate a anycast prefix seed to these node. Now traffic from R1 to R6 can pass via this way or it can pass through via this way as well, does not matter, but it has to pass through this region. And if this node fails due to any reason, traffic will be rerouted via this path, but I am still meeting the compliance. And there can be multiple of such nodes here representing a region. So that is a use case for Anycast SID. I hope this is clear to you guys. So now let's just move to the next set of prefix SID, which is adjacency segment. So adjacency segment, or also called as adjacency SID, are basically local to the router or the node which advertise it. These type of SIDs are used for very granular control. To give you an example, let's say I have this R1 and R2 and I have multiple link. You can enable any IGP like OSPF or ISIS. Both of them support segment routing. By default, your IGP can pick any path. It can pick the path 1, the second, or the third. But what if I want to mandate that from R1 to R2, the traffic should only pass via link number 1? And remember, this is a MPLS data plane that we are talking here. That means the packet forwarding that will be happening on this in the data plane are labeled packets. So how can I ensure in the MPLS data plane that the packet should pass through via link 1 only when it is up? That is what the adjacency SID help us to do. And because this link 1, 2, 3, they are only on R1, Here I can have Rx, but this node will not understand any of these adjacency seed because they are local to R1. So, from the definition perspective, adjacency set is associated with a local interface of a router. One question that I often get here that Sunil, why in the first place they are made local? I do understand that this interface 123 is local to R1, but why the SID value has to be local to R1? That value can be globally unique as well. Well, hypothetically, it can be unique, but then think about the amount of SIDs that you will be having. Because here this router have three interfaces. There can be another router with many interfaces. And if we go and assign unique seed to all the interfaces in your domain, the amount of seeds that we need will explode. But at what cost? Do we really need that global significance for adjacency segment? Because what my requirement is that when the traffic come to R1, it should pass through via link 1. So if R1, when the traffic come from Rx to R1, if R1 is understanding that instruction, my purpose is getting achieved. So that way, you don't need the global significance for these adjacencies said where only that particular node has to act on that instruction. So all I need is whatever this SID, let's say 10,001. When the packet reaches to R1, this SID, this label should be at the top. That's what all I care. So with that perspective, it does not make sense to have a global significance for the adjacency set, and they are local in nature. To understand it with this topology, I have, let's say, R1, R2, and let's say this is R6, for example. And here I have those link 1, 2, 3. So with this adjacency segment, IGP will basically allocate a different SID to each of these interfaces. And when the packet comes, all I need to do is, what I need to say that from R1, the packet, first it should go to, let's say, 16002, which is the node SID for R2. Then it should take this path, and then it should go to this. Now, of course, this will be in the reverse order where this will be the top label. Then when the packet reaches to R2, this label will be exposed. I hope by now you understand implicit null, but I will talk about that as well in our upcoming sessions. And once this label get popped off, the label which gets exposed is 16006. So the packet which using this link come here, get forwarded to R6. So that is how we are forcing on R2 via this label which is here. That packet should use this second link from R2 to R3. This is the purpose of adjacency SID. So far we have talked about prefix SID, then node SID, Then any caste said, and now adjacency said. Is that it, or are there more type of seeds that are available in segment routing? Well, yes, there is more, which is the BGP prefix seed. So these are the seeds which are associated with BGP prefixes. But I think for this video, this is enough. We will talk about BGP prefix seeds in some future lectures. So with that, I hope this was informative and thank you so much for viewing.